Welcome to this video on operations on functions. Let's begin. The following show you the different operations we can do on functions. Let's read through them and make sure we understand the notation. The first one says f plus g of x. This can be rewritten as f of x plus g of x. In other words, this is just asking to add the two functions f and g together. The next one says f minus g of x. Again, this is just a shorthand notation for saying that we want to subtract the two functions f and g. Likewise, when we say f times g of x, this means to multiply the two functions f of x and g of x. And last but not least, when we divide f and g, this means to divide the two functions, of course with the restriction that, remember, we cannot divide by 0. Therefore, the denominator, in this case g of x, cannot be equal to 0. Let's apply these properties in the following example. Example 1 says, complete the table below, given that f of x equals x squared minus x minus 2, and g of x equals x plus 1. So first, we're asked to interpret this symbolically. Notice that our argument is a variable. Let's just briefly look at A, B, C, and D and go through them. So A, our argument is a variable. In B, our argument, our x value, is just a number, it's 5. In C, we have a variable, and in D, we have a number. So again, we need to be able to interpret this notation both symbolically and numerically. So the first thing I'm going to do for part A is I'm going to rewrite this as f of x plus g of x. Because remember, right, that's what this first guy says. It says that f plus g of x is equal to f of x plus g of x. So let's just write it that way, okay? So then we have to remind ourselves, okay, cool, well, what is f of x? Well, it says that f of x is equal to, let's use a different color here, f of x equals x squared minus x minus 2. Okay, so in place of f of x, I'll write it in the same color, in place of f of x, we're going to write this whole expression. Okay, so then we have plus g of x. Well, g of x is just x plus 1. So now we have this whole expression, and we can start thinking about what are the like terms. So here we have an x squared term. Do you see anywhere else that we have an x squared term? I don't see any, so I'll just write x squared. Okay, what about linear x terms? Well, I see that I have a minus x and a plus x. So let's write those next to each other, minus x plus x. Then I can see that I have a minus 2 and a plus 1. Those are like terms. So let's, minus 2 and plus 1, so we'll write those next to each other. Okay, well, what is minus x plus x? Don't they cancel out? So it's just 0, isn't it? So then, last but not least, we have the minus 2 plus 1, which gives us minus 1. So that is our final answer. So f plus g of x is x squared minus 1. Now, it's true that this is a difference of squares and you can factor it, but that's sort of beyond the scope of what this example is asking us to do. So we're just going to leave it just as you see it right there. So part B, it's the same composition, right? It's still f plus g, but instead of x, now we have f plus g of 5. So let's see what that looks like. So we have f of x still, right? Remember, f of x is x squared minus x minus 2, right? And we still have g of x, and g of x is x plus 1. And we're adding those. Okay, so what's different here? Well, the thing that's different is that we're replacing x. Anytime we see x, we're going to write 5. So we're going to have 5 quantity squared minus 5 minus 2 plus 5 plus 1. Okay, so you can do this however you want to. I'm just going to use the chalkboard space over here. 5 squared is 25. So I have 25 minus 5 minus 2 plus 5 plus 1. 25 minus 5 is 20. So we have 20 minus 2 plus 5 plus 1. This is 18. So I have 18 minus 5 plus 1. 18 minus 5 is 13. 13 plus 1 is, last but not least, 14. So the final answer here is 14. So let's just step back for a minute and compare and contrast part A and part B. Notice in part A, I still have x. I still have a variable in my answer. And the reason is that I wasn't given a value of x. I was just given a symbolic representation, right? However, in part B, I was given a numeric value of x. They're saying, what is f plus g when x equals 5? So anytime you see a number in here and not a variable, your answer should be a number. Anytime you see a variable in here, then that variable should still be in your final answer. So kind of keep that in mind as you go through these problems. All right, let's do the next one, f minus g of x. So remember, this is the same as f of x minus g of x. Okay, so, well, what is f of x? F of x is x squared minus x minus 2. And what is g of x? Well, g of x is x plus 1. Now, notice I did a very important thing, and the important thing that I did is that when I wrote that subtraction sign and then I wrote g of x, I put g of x in parentheses. And the reason that's so important is that I'm subtracting the whole thing. I'm not just subtracting the first term. So remember, what this does for us, remember there's really a 1 hiding out here. So when we subtract this, what we do is we can multiply both terms inside the parentheses by negative 1. So we can rewrite this as negative 1x minus 1. Okay, and I'm going to take a minute and just bring down the rest of the terms from the first function. Okay, so now notice this is going to give us a slightly different answer from what we got in part A. We still have our x squared, but now we have a minus 1x minus 1x. That's going to give me minus 2x. Okay, then we have a minus 2 minus 1. That's going to give me a minus 3. So my final answer is x squared minus 2x minus 3. Again, I know that the x should still be in my final answer because, right, I was not given a value for x in the question. All right, so let's do part D. We have f minus g of negative 1. So again, I'm going to rewrite this as f of negative 1 minus g of negative 1. Okay? So I'm going to first rewrite this function symbolically. So it's x squared minus x minus 2 minus parentheses x plus 1. Okay? After I do that, I will replace all of the x's everywhere in both equations with the number negative 1. So let's go ahead and do that. Notice I used parentheses to build a spot, right, a placeholder for them. This is very important because if you remember, for example, negative 1 squared is not the same as negative 1 quantity squared. Okay, if you type them into your calculator in those two different ways, you will get different answers. This is negative 1, this is positive 1. Okay, so the parentheses in some cases aren't even optional, they are mandatory if you want to get the right answer, which I think we do. Okay, so negative 1 quantity squared, right, that's negative times negative 1, right, negative 1 times negative 1 is positive 1. Okay, then we look here, we have minus a negative 1. Well, minus a negative is the same as plus a positive. Then we have a minus 2, so we'll write minus 2. Okay, and then I'm just going to copy this negative sign real quick. Okay, minus. And then let's look at what's in parentheses. Well, what is negative 1 plus 1? Isn't negative 1 plus 1 just 0? That was pretty simple, right? So I can further simplify this. 1 plus 1 is 2. Right, so then we have 2 minus 2 is 0. So my final answer, after all that work, is that f minus g of negative 1 is 0. So now, let's keep going with parts E, F, G, and H. Now we're going to be looking at the f times g and f divided by g. Okay, so f times g of x is the same as f of x times g of x. Okay, and it's going to be very important that we write these things with parentheses. So I have x squared minus x minus 2 in parentheses times x plus 1. Okay, so this is the part where we use our distributive property. So x squared times x is x to the third power. Okay, then we have x squared times 1, that's x squared. Okay, then we have negative x times x, that's negative x squared. And we have negative x times 1, which is negative x. Okay, so then we have negative 2 times x, that's negative 2x. And last but not least, we have negative 2 times 1, or negative 2. All right, so hopefully you can see here that some of these things are like terms, and so there's a little bit more we can do. So I have a plus x squared minus x squared. What's going to happen to those? Well, when we add them, it gives us 0, so they cancel out. What about minus x and minus 2x? Well, when we put them together, it gives us minus 3x. Notice that x cubed and 2 are sort of standalone values. They don't have anything to be combined with. So my final answer is x cubed minus 3x minus 2. All right, so if we look at our next example, we can see that this time, right, we're still multiplying our functions, but we have a value, a number to put in place of 2. So we're going to find, well, what is f of 2 times g of 2? Well, f of 2, that's going to be 2 quantity squared minus 2 minus 2. Okay, and we're going to take that whole thing and we're going to multiply it by 2 plus 1. Okay, so let's think about this. 2 squared is 4. So we have 4 minus 2 minus 2, right? And then, of course, 2 plus 1 is just 3. Okay, so 4 minus 2 minus 2, what is that? Well, isn't that 4 minus 4 or 0? So we have 0 times 3. Anything times 0 is just 0. So we did all that work and we found that f times g of 2 is 0. All right, last one. We're going to be dividing these functions this time. So this is, remember, f of x divided by g of x. So we're going to have x squared minus x minus 2 in our numerator, right? And then we have x plus 1 in our denominator. So this should remind you of rational functions, which we've done before. That's exactly what we're doing here. And if you remember, when we worked with rational functions, one of the things we had to do was we had to factor our polynomials. So you can use the AC method, or whatever method you prefer. When we factor x squared minus x minus 2, it factors out into x plus 1 times x minus 2. And if you don't believe me, you can FOIL that out. Okay, so remember, I always made you find or list your restricted or excluded values. And again, if we go back here, right, look at this guy. This also points out the fact that we cannot let this denominator be equal to 0, right? We're not allowed to divide by 0, okay? So let's list our restricted values first before we go any further with this problem, okay? So remember, restricted or excluded values, it means the same thing, okay? So remember that the denominator is where they come from. So we say that x plus 1, that's our denominator, cannot be equal to 0. So solve for x, we say that x cannot be equal to negative 1. Okay, this is important because in a second you can see these guys are going to cancel out, right? So my final answer is x minus 2, comma, right? I have to mention that there is a hole at x equals negative 1. Okay, that has to be part of my final answer. All right. So last but not least, we're going to do the same thing again, only this time we're going to put 0 in place of x. So we have f of 0, so that's 0 squared minus 0 minus 2 over 0 plus 1. Well, that's just negative 2 over 1, or negative 2. So that's it. That's my final answer. So let's do this whole process over again with one more example. If at this point you feel like you're really comfortable, you can always start the homework. You don't have to watch and go through both of these examples. Okay. So in this problem, it says f of x is equal to 4x plus 3, and g of x is equal to 2x minus 1. So again, in the first problem, we are asked to add these. And again, notice that because x is still just x, right? It's not a number. This is being done symbolically, and our answer should still contain x. Okay, so f of x is 4x plus 3. Okay, g of x is 2x minus 1. Okay, so we'll just do a little bit of rearranging of the furniture so that our like terms are adjacent. So that gives us 6x plus 2, and that's it. We're done. Okay, for the next one, we want to find, well, what is f of 5 plus g of 5? Okay, so we have 4 times 5 plus 3 plus 2 times 5 minus 1. So we have 20 plus 3 plus 10 minus 1. So I believe that gives us 33 minus 1, or 32. Okay, again, remember, since there's an x here, right, it's symbolic, x should be in our answer. Because this is a number, then our final answer should be a number. Okay, if you're given a value of x and then somehow when you have your final answer, there's still an x in your answer, you did something wrong. Okay, so be vigilant and watch those. All right, next one, we have f of x minus g of x. Okay, so again, we have 4x plus 3 minus, remember you got to have parentheses here, it's very important. So we have minus parentheses 2x minus 1. Okay, I'm going to write a 1 out here to remind myself that everything inside the parentheses is being subtracted, meaning that everything inside the parentheses is changing its sign. So I have negative 1 times 2x, that's negative 2x. Then I have negative 1 times negative 1, and that's plus 1. Okay, let's bring down the rest of our problem, 4x plus 3. Okay, then I'll just take a second and rewrite it so that like terms are adjacent. Okay, so I have 4x minus 2x, that's 2x, 3 plus 1 is 4. So that's my final answer. Again, it makes sense that my final answer contains x since my question contains x. All right, let's do this last one on this page. So this time we have f of negative 1 minus g of negative 1. Okay, so f of negative 1 is 4 times negative 1 plus 3 minus, and this is important, right? We have to have those parentheses. Here's our parentheses, minus 2 times negative 1 minus 1. Okay, so let's evaluate this one. 4 times negative 1 is negative 4. Right, and negative 4 plus 3 is negative 1. Okay, then let's figure out what's in the parentheses. 2 times negative 1 is negative 1. 2 times negative 1 is negative 2. So then we have negative 2 minus 1. Okay, so I'm going to write this over here because I'm out of room, as you can see. So I have negative 1 minus parentheses, negative 2 minus 1. Well, negative 2 minus 1 is just negative 3, isn't it? Okay, what do we do when we have minus and negative? Well, we turn it into plus a positive. So what is negative 1 plus 3? Well, it's positive 2. So f minus g of negative 1 is positive 2. All right, so let's do this last page. Now we're working on multiplication and division. And again, the functions are exactly the same. Okay, so we have 4x plus 3 times the quantity 2x minus 1. Okay, so we're going to FOIL. So we have first, 4x times 2x is 8x squared. Okay, then we have our outer terms, minus 4x. Then we have our inner terms, plus 6x. Then we have our last terms, that's minus 3. Okay, hopefully you can see that these middle terms are like terms, which can be combined. We combine them to get 6x, we combine negative 4x and 6x to get 2x, positive 2x, and then we have a minus 3. So that would be our final answer. Now you might be thinking, hey, couldn't we factor that? Couldn't we use the AC method? Probably, but that's beyond the scope of what this question is asking us to do, right? So we're going to just leave him alone. All right, the next one, again, is exactly the same, except, right, in place of x, what are we putting? What value do we want? We want 2, okay? So it says f times g of 2. So 4 times 2 is 6. 6 plus 3 is 9. 2 times 2 is 4. 4 minus 1 is 3. So last but not least, we have 9 times 3, which is 27. Again, it makes sense that this is a numerical answer because we are given a numerical value for x. All right, we're almost done. So this one, we're going to have f of x divided by g of x. So that's 4x plus 3 divided by 2x minus 1. And I don't see anything that we could factor out, so I would circle that as our final answer. We can mention the restricted values, right? The restricted values come from the denominator. We can't divide by 0. So we can just take a minute and solve. So we have 2x can't be equal to positive 1. Divide by 2, x cannot be equal to 1/2. Okay, so we can include that in our answer. X cannot be equal to 1/2. Whoop, there we go. All right. Okay, so last but not least, they want us to find f divided by g of 0. So in other words, what is f of 0 divided by g of 0? Okay, so we have 4 times 0 plus 3 over 2 times 0 minus 1. Well, that's just 3 divided by negative 1 or negative 3. And that's it.